Most people think the internet is wireless. Data feels weightless. Messages appear instantly. Videos stream from the cloud. It all feels abstract, untethered from the physical world. But the truth is far less modern. Almost everything you do online depends on a handful of cables lying silently on the ocean floor. Thin, fragile lines stretched across thousands of kilometers of darkness. And if just a few of them stop working, entire countries don't just lose Netflix. They lose banks, hospitals, air traffic coordination, emergency services, markets. This is the unseen system that keeps the modern world alive. The internet looks decentralized. Billions of devices, millions of servers, thousands of companies, no obvious center, no visible backbone. That illusion is reinforced every time Wi-Fi connects without a wire, every time a phone switches towers seamlessly, every time a video loads from a service that claims to live in the cloud. So the natural assumption forms: the internet is resilient, redundant, too big to fail. And in some ways that's true, but only at the edges. Beneath the abstraction, the internet is brutally physical. Over 95% of all international internet traffic moves through undersea fiber optic cables. Not satellites, not radio, cables. They lie on the seabed, across oceans, through trenches, past fault lines and along coastlines, carrying pulses of light thinner than a human hair. Each cable contains bundles of optical fibers, protected by layers of insulation, steel armoring, and waterproofing. But despite that engineering, they are far more vulnerable than most people imagine. Some are thinner than a garden hose, and almost all of them converge at a surprisingly small number of landing points. This wasn't planned as a single system. The first undersea cables weren't for data at all. They were for telegraphs. In the 19th century, nations raced to connect continents with copper wires so messages wouldn't take weeks by ship. Those early cables failed constantly. Saltwater corrosion, pressure, manufacturing flaws. Entire lines would go dark without warning. But each failure taught lessons. By the late 20th century, fiber optics replaced copper. Capacity exploded, costs dropped, globalization accelerated. Private companies laid cables where it made economic sense, between financial hubs, between dense population centers, along politically stable coastlines. No single authority coordinated this growth, which means no single authority designed it for failure. The weakness of undersea cables isn't usually sabotage, it's accidents. Fishing trawlers dragging anchors, cargo ships drifting off course, underwater landslides triggered by earthquakes. One anchor can do more damage than a cyber attack. In 2008, a ship's anchor near Alexandria severed multiple cables in the Mediterranean. Internet speed slowed or vanished across parts of the Middle East, India, and Southeast Asia. In some countries, over 70% of connectivity disappeared instantly. Banks couldn't process transactions, call centers shut down, stock trades stalled, and most people had no idea why. When a cable fails, traffic reroutes, but rerouting has limits. Alternate paths are longer, congested, more expensive. Latency increases. Systems that rely on precise timing begin to drift. Financial markets depend on microseconds. Power grids depend on synchronized clocks. Mobile networks depend on constant coordination. As congestion builds, small delays amplify. Not everything fails at once, which makes the danger harder to see. More cables exist than ever before, but redundancy is uneven. Wealthy regions have dozens of routes. Developing nations often depend on just one or two. Some entire island nations connect to the global internet through a single landing point. Repair ships are few, specialized, slow, weather-dependent. A single fix can take weeks. And because cables are owned by private consortia, no global authority is responsible for resilience. Everyone assumes someone else has handled it. Cloud computing didn't reduce dependence on cables, it increased it. Streaming, remote work, digital banking, AI inference, all of it concentrates traffic into data centers that rely on the same physical routes. At the same time, maritime traffic is increasing. Geopolitical tension is rising. Surveillance and mapping of cable routes is improving. What was once obscure infrastructure is becoming strategic terrain. The internet feels eternal, but it's held together by thin glass fibers, a few ships, quiet assumptions. The system works not because it's invincible, but because failure is rare enough that most people never notice it, until they do. Most people assume that critical systems are watched constantly. That if something this important existed, someone would be responsible for protecting it. But undersea cables aren't guarded the way people imagine. They aren't monitored in real time. They aren't surrounded by defenses, and they aren't treated as a single system. They belong to private companies. They cross international waters. They fall between jurisdictions, which means no one sees the full picture. Each operator protects their own segment. Each country worries about its own shoreline, and everyone assumes the rest of the system will hold. Not because it's guaranteed, but because it always has. The modern world doesn't collapse all at once. It frays, it stutters, it slows. And the systems we depend on most are often the ones we understand least. The cables at the bottom of the ocean were never meant to be noticed, but they are the reason the digital world exists at all. This was one unseen system. There are many more. If you want to understand the hidden infrastructure that quietly shapes everyday life and what happens when it starts to fail, subscribe to Unseen Systems, because the most important systems are rarely the ones we're taught to see.